Okay, I finished the full project. Now you can observe. So in this folder, if you are having only these many files, this is the database from which you are getting all the details, like to whom the vehicle is registered and all. This is the program we'll run for the GUI. This is the program which the police officers will execute. So we'll do python GUI.py. Then the police officer has three options. One, to enter some new details into the database. Second, to run the helmet detection. And third, to generate the challans. All these three are automatic. So in the first case, first we'll see what is in the database. Here I'm saying select star from vehicles. Vehicles is the table and vehicles.db is the database name. So we've given the same name. There's only one table in our database. And these are the three columns. So first column is license plate number. Second column is name of the person. Third column is address. So first four are all nonsense. They're not important. But the fifth one is these five are for five different license plate numbers. First four I did just for first five I did just for testing. The sixth one, which is this, is the real one. So here I've given the license plate number. Here I've given my name and the address in which the person is living, not the address of registration. So just these three values are there. So now we can add to the database. So it's asking me to add a license plate. So I'll go here. Just here I've written something. Don't worry about it. Yes, this is GJ01 UK 5541. This is the name of the license plate. Name on the registration. This time I'll type Rahul. He lives in Chennai. This is so that the address is so that they can easily mail the challan to the offender. So we'll click enter. Here it says records added. Here we'll see if it's added in the database. So again I'll do select star from vehicles. Here this record is added, meaning the entry is successful. So now I can close this. This is the main page is still there. Now I'll run the main program. The main one is, it'll run it on this one, demo input.mp4, which is here. This video will be doing the like on this will be running our program first. So here I'll do click to run helmet detection, but before that I'll show that the folders are empty so that you can observe. Challans is nothing here, violations it's empty, cropped images empty, everything is empty only. Now when we run the program, all these folders will be full with some images which are important for us. So now we'll run the helmet detection. Just click the button, it will start. It's running on this terminal here. So in this place the actual result is being shown, the output. It's slow because our system is also slow, but now it's saying skipping. So it skips based on the speed of the system so that it can run in real time. Otherwise it will be lagging behind the CCTV footage. It will be like running code for yesterday's CCTV. To avoid that, we'll make it catch up by skipping the frames. So we are skipping some data, but you see the big images are the violations that they're showing on the screen. It's stored in that folder, which I'll show later. See again, we keep again, one more. So like this it will do all the violations. So the video is around 2.5 minutes. This will also take around 5 minutes. The green box is for the helmet. So you can see the officer is wearing the helmet. So the green box is there. So on all this there's no helmet and all, that's why there's no output.
કેસમાં થતા મૃત્યુ છે. પહેલા આ રકમ 25,000 રૂપિયા હતી. કિશોરોએ તો એટલો કરીને 10,000 તેનો દંડ વાહન બદલે. કહેવું છે કે આ નિયમથી વાહન ચાલકો ધ્યાન રાખશે અને દંડના ડરે નિયમનું પાલન કરશે.
ખાસ કરીને લોકોમાં એક જાગૃતિ આવશે અને જ્યારે વધુ પ્રકારમાં પેનલ્ટી ભરશે તો એના વાહનો ચલાવવામાં તેઓ કાળજી રાખશે.
મહત્વનું છે કે દેશમાં દર વર્ષે અનેક લોકો અકસ્માતમાં જીવ ગુમાવે.
Little bit lagging because in the beginning it's measuring the frame rate so that it can catch up. So it's little bit behind, but it actually detects all the objects. The helmet is green color, rest it will detect in some other colors. See, again it's detecting violations. After this is over, for whichever violations we have, we need to read the license plate and generate the challan so that the officers can send it. This is over. Now the program is finished running. So I'll show the challans is still empty because we have to click this button, click to generate challan, so it's still empty. Then cropped images, see so many other, these are all the violations for which we haven't done the LPR yet. After the LPR some will get eliminated, like here there is no license plates, obviously it has to get eliminated, which I'll show later. These are all the violations. Okay, now for the final part, I'll run click to generate challans. Here it is printing the output of the LPR program. So once it gets the output, it will go to the database, put the license plate, check the details and print the challan out, all this automatically. So this is almost over. See, so it's matched with the database. Now it will print 2 challans. We need to observe 2 challans, one for Rahul, one for Sriram. And now it's finished. We'll go to challans. See, there are 2 now. The first challan, we can observe license plate and the violation. The proof is there in the challan itself. Fine is there. The address is there, name is there, license plate is there. This is printed automatically, this challan, along with the date of the program. It's not the date of violation, it's the date in which the program is running. Here also, so we've generated 2 violations. There were many more, but the problem was that either LPR was not working or it's not there in the database. So if we want to punish more people, we need to have clearer cameras and we need to put the data in the database so that we can send the challans. These 2 challans are written very nicely. Okay, that's it. The program is over. Now I'll explain how it works. So this is all for the main GUI for TK. See, labels are there, the first label, then 3 buttons are there. Based on the button, it runs the function. The first button is open the new window, which is for opening the database entry system, which is this one. This one is all the way is here. We have 3 labels with 3 entry and 1 button. When you click the button, it enters the records. How it enters the records? With these 3 entry, E1, E2, E3 means these 3 text fields here. It takes the input, then it inserts using the SQL command. For this, you need to read about SQL if you want to understand. Yeah, the second one is run the helmet detection. This will run the program which I sent in the last video, but I'll show it again anyway because this time it's a video, but the rest logic is the same. Then the third one will be generate challans. For generating the challans, what it will do is it will run this lpr.py program, which is this one. lpr.py runs that deep license plate recognition, which is that API which we downloaded from GitHub. For that, we need to register for an API key which allows us 2000 pictures every month. Out of that, I used almost 100 till now, so I need to be careful. It writes it into this file, then it stores it into this .jpg in the folder called violations. Yes, the violations are here, these 6 violations. If it's able to recognize, otherwise it just removes it from cropped. Either way, it's getting removed from cropped images. If it's getting detected, it gets put in violation, otherwise it's just deleted. So that now we go back here. After this is over, now last time we were writing into database, now we need to read from it. What information is already there, we're not changing anything now. So here it says select star from vehicles where plate equal to this plate which we have gotten from LPR. From that we are getting these values we've gotten. From that, all this code is for printing that PDF. This PDF which for printing all this, like Challan, Traffic Police Department, like here, like that. And at the last, we put the image for the proof. So that's 2 things are over. Now I'll show the for the main thing, the helmet detection. So here we were running the program YOLO which is this one. So in this YOLO this time we are giving input as we're giving input as video. So in the YOLO video, it detects this input, and so we need to detect the video. It calls detect video function, which is here. In this detect video, first it will capture the video from that video, that demo input.py which I showed earlier. Then this is all for extracting the frames. So from the video it will take frame by frame. So this is for skipping. This common FPS is what the FPS we are getting. Video FPS is what the FPS from the video is. So if the video FPS is 25 but our CPU can process only 1, then we need to skip 25 frames. 1 frame we need to do detection, 25 we need to skip, because the system is slow and we want real-time management. So it gets the image from the frame, then it does the detection on that image itself. So the important function is detect image. So in this detect image, first it detects the helmet in the image. From that we get the helmet box, which is that green color box. We are getting all the corners, so that we know how the box is from the program. This HDY is helmet detection YOLO, which is this program. From here it does all this program, which I've taken from GitHub. It returns the helmet. The score boxes is for the confidence, like 0 to 1. Then this is for the remaining objects, that many boxes were there. For that we've done it. Then for this we are going to add it to many arrays, so that inside we can access from here. So inside this we want to display the boxes themselves. This is just to calculate where the boxes are. All this is to display it on the screen. So in the video itself you are seeing that. So for all this you need to do. So id, c in out classes. These are all the objects that are detected. So for every object they are going to show it on the screen with a different color. So for that all this code is there to draw the rectangle. Now the logic here is similar as the image detection which I sent earlier. First it will check the motorbike boxes, then it will check the person, then it will check the helmet where the boxes are. So if the rider boxes are getting overlapped with the biker objects, then it will check if there's a helmet for any of the people on the bike. The program does not check whether pillion is wearing. Any one person has to be wearing helmet. Reason for this limitation is, suppose a pedestrian is walking in front of the bike, he shouldn't get punished for it, because obviously pedestrian won't be wearing the helmet, and the program will think that it's somebody without a helmet is sitting on the bike. So for that only we are fine if any one person is wearing a helmet. So we are checking for each person if he's wearing a helmet. If he's wearing the helmet, that flag is 1, flag is 0. Here it will crop the common part of the bike and the person if there is no helmet anywhere. So we get the full image which you can give to the LPR. So once that is over, we will return the image. That's that cropped image which we showed, the violation itself, because it's a combination of the violating rider with the object. Then you will then it gets returned and it will write it to the output video. Okay, that's it.